Hello everyone, hope all of you are doing fine and you are following our videos related to the previous year questions in CSAT paper. Hope they are helping you. So give us the feedback then and there only in the YouTube so that we can correct ourselves or the proper course correction can happen. Okay, coming to our series, like we have done 2024, then 23, we are into 2022, half of the paper is done up to 40 questions and now we are into other half of 2022 paper. So let me look into the question 45. 5 friends P, Q, X, Y, Z purchase some notebooks. The relevant information is below. Z purchased 8 notebooks more than X did. So Z is equal to X plus 8. Straight away you should start writing the equations. P and Q together purchased 21 notebooks. P plus Q is equal to 21. Q purchased 5 notebooks less than P did. So Q is equal to 5 less than P. So here we have two equation in two variable. There we directly get the relation between P and Q. Okay. X and Y together purchased 28 notebooks. X and Y together is 28. Then P purchased 5 notebooks more than X did. So P is equal to X plus 5. So here we have totally 5 variables and 5 equations we have. So easily we can get the solution of this. So this particular equation P plus Q is equal to 21, Q is equal to P minus 5. Put this Q value here, that becomes P minus 5. That is 2P minus 5. 2P minus 5 is equal to 21. So 2P is equal to 26. So P is equal to 13. P is equal to 13. When P is equal to 13, Q should be 8. So P is 13, Q is 8. So straight away we have X plus 5 is equal to P, but P is equal to 13. So X is equal to 8. So Z is equal to X plus 8. So Z is equal to 16. Then Y, X plus Y is equal to 28. X is already 8. So Y is equal to 20. This is what we have. All the values we have. Then if each notebook is priced rupees 40, each notebook is rupees 40, then what is the total cost? So total, you do the total. So 13 plus 8, 21, 21 plus 8, 29 plus 16, 45 plus 20, 65 into 40. 65 into 40, that is 2,600 rupees. This is a simple problem. So now onwards, I will not be looking into those straightforward questions. But here the clue is what? 5 variables, 5 equations. We can get the complete solution. That is what we did. Next. So question number 46. A man started from home at 2:30, that is afternoon 14:30, and drove to a village, arriving there when the village clock indicated 15:15 hours. So when he started from his house, the house clock was showing this one, and when he reached the village, it was showing 15:15. Then after staying 25 minutes there, so he spent time 25 minutes there, he drove back by a different route. He drove by a different route of length 1.25 times. So while going, if distance was d, while coming back, his distance was 1.25 d, because 1.25 times of the, while going, his distance was d, while coming back, his distance was 1.25 d. At rate twice as fast. So initially, if his speed was s, now his speed is twice. So 2s is his speed. And when he reached house, it was 1600 hours, that is 4 o'clock in the evening. As compared to the clock at home, the village clock is. So what we are seeing in the house and the village, they are not the same. They are not the same. The clocks are proper, but the thing is, like, they are not same. They are not same. So that is why we have to consider only one time here, either village time or home time. Since he is seeing the home time while leaving, and while come back, he see the home time again. So that is why our reference here has to be the home clock. Let us not worry about the clock in the village. So while going, he saw it was 230. While coming back, he saw it was 1600 hours. So totally, he has spent 130. That is 1 hour 30 minutes. That is 90 minutes. That is 90 minutes he has spent totally. 25 minutes he spent in the village. So 25 if you subtract, then it is 65 minutes. It is 65 minutes that he spent. 65 minutes he has spent in the route itself, while going and while coming back. But total time, this is nothing but while driving distance D, he went with speed this. Then while coming back, he drove this distance, that is a different distance, and with the speed 2 times of that. 2 times of that. And totally he has taken how many? 65 minutes. He has taken 65 minutes. So here, if you calculate this plus this, D by S is nothing but the time taken while going. Time taken while going. I'll take this D by S is equal to T. But while coming back, he has taken something in terms of D by S only. So I'll take that as T. And 1.25 divided by 2 is equal to 0.625 T. 0.625 T. So T plus 0.625 T is equal to 1.625 T. So total time that he has taken is 1.625 T. So that is equal to 65 minutes. So 1.625 T is equal to 65 minutes. So T is equal to 65 divided by 1.625. So if you get rid of the decimal point, it should be 3 zeros here. So 65,000 divided by 1625. When you cancel this, this will be 40. So real time that he has taken to go to the village, that is T, is equal to 40 minutes. That is equal to 40 minutes. This is what we want. While going, he took 40 minutes. So he left at 14:30. So if I add 40 minutes to this, by the time he reached the village is 15:10. It is 15:10. So actually, if he believes his house clock, it is 15:10. But his village clock is showing 15:15. That means this clock is 5 minutes plus. That is 5 minutes faster compared to the clock at the house. So village clock is 5 minutes fast. So this is bit a complicated problem, because while going, if he takes time T, while coming back, he will take 0.625 T. So total time is 1.625 T. That is equal to 65 minutes. T is equal to 40 minutes. But he takes 40 minutes, but village clock is showing other thing. That is 5 minutes extra it is showing. So then village clock is 5 minutes faster. Okay, but this is a good problem, but bit time consuming. Next. A person X wants to distribute some pens among 6 children, A, B, C, D, E, F. Suppose A gets twice the number received by B, 3 times what C gets, 4 times what D gets, 5 times what E gets, and 6 times what F gets. So this is how it has been distributed. It looks like this person has got F, but 6 is just a confusing thing here. Here the highest number of pens got by A, because A is equal to double that of B, triple that of C, 4 times that of D, and 5 times that of E, and 6 times that of F. So here F got the least, A got the highest. Now, what is their question? What is the minimum number of pens X should buy that number of pens one gets is an even number? So in such cases, when like different variables are equated, directly you go for the LCM of these coefficients. LCM of the coefficients. So here 1, here 2, 3, 4, 5, 6. So LCM of these coefficients is equal to 60. Is equal to 60. 1, 2, 3, 4, 5, 6. the LCM would be 60. So now what we have to do is, we have to equate all these to 60. Then we'll get the value A is equal to 60. So A is equal to 60, B is equal to 30, C is equal to 20, D is equal to 15, E is equal to 12 and F is equal to 10. So when you compare the number of pens possessed by them, all of them are not even number. All of them are not even numbers. So look at this 15. 15 is an odd number. To better that one, that means to make that even number, we have to multiply each number here by 2. Then in that case, A will get 120, B will get 60, then C will get 40, D will get 30, and E will get 24, and F will get 20. These are the numbers that they have to get so that they get the even number. So when you add all these things, the answer is 294. This is the LCM problem straight away, but they want the even number. That means we have to multiply by 2 to what they possess. So total is 294. Next question. Again, this is data insufficiency. Statement. Who is sitting on the immediate left of A? Who is sitting on the immediate left of A? Let us construct the diagram here. A, B, C, D, E, F are sitting equidistant from each other around a circular table. Okay, there are 6 people, we have to divide like this. They have to be equidistant. Then, who is sitting on the immediate left of A? How do you decide? Looking at the statement. Let us read only statement 1. B is sitting opposite of C. So, first person can sit anywhere. Then, D is sitting opposite of E. But where D? D has 4 places. Then, depending upon D's place, E will sit. So, can I solve this question? Who is sitting on the immediate left of A? Immediate left of A. A can come anywhere in these 4 places. I cannot tell who is sitting on the immediate left of A. We cannot tell that one. So, statement 1 alone is not sufficient. Statement 2 alone. So, now I have to forget statement 1. Now, F is sitting on the immediate left of B. F is sitting on the immediate left of B. So, if F is looking like this, then B is that side. So, F is on the left side of B. So, this is what we have from this one. F is sitting on the immediate left of B. But again, here I cannot tell who is sitting on the immediate left of A. I cannot do that. So, club both the statements now. Club both the statements. B is sitting opposite of C, fine. And D is sitting opposite of E. Now, D and E have this place. They cannot come here or here. They can come here. So, D or E here, then we are left with only A. But D or E, I don't know. So, now try to answer this question. Who is sitting on the immediate left of A? See, I can tell immediate right of A is C. But here, either D or E will come. So, even by combining both the statements, I cannot answer this question. That is why the answer becomes D here. What is the age of Manisha? Okay, statement 1. Manisha is 24 years younger than her mother. So, Manisha is 24 years younger than her mother. So, I will take big M. This is small m. Okay, m minus 24. I want the age of Manisha. Unless I know the mother's age, I cannot get the answer. So, statement 1 alone is not possible. 5 years later, the age of Manisha and her mother will be in the ratio 3:5. Yeah, statement 2 alone, it is giving me the ratio. When Manisha is 30, mother can be 50. If Manisha is 60, mother can be 100. So, I cannot conclude even on the base of second statement alone. So, now I have to club both of these. So, here when we say Manisha is 3 and mother is 5, in this case what I can do, Manisha's age is 3x and mother's age is 5x. So look here. So I can substitute this. Manisha's age 3x is equal to mother's age 5x minus 24. So if I bring 3x this side, it becomes 2x is equal to 24. So x is equal to 12. X is equal to 12. In this case, 3x is Manisha, that is 36 years. Mother is 5x. 5 into 12, it is 60. So what do you want? Manisha's age is 36. Using both the statements, I can get the answer. So this is a simple problem. Here we got one relation between both the ages. Here we got another relation. Now we could have solved that thing very easily. So C is the answer here. Next question, 50th. Lectures A, B, C, D, E, F, each of 1 hour duration are scheduled between 8 a.m. to 2 p.m. Fine, 8 a.m. to 2 p.m. 6 hours time. Pretty okay with that? Yeah. Which lecture is in the third position? I want this answer. That is third position I want. Now, lecture F is preceded by A and followed by C. F followed by C preceded by A. So out of 6 lecturers, I have got only the details of 3. How I would say that it is the third period? It can be anything. It can be anything. Any person is, he can be the first, he can be second, third, or he can be fourth, fifth, sixth. It can be anything. So only on the basis of statement 1, I cannot answer. Now statement 2, there is no lecture after B. That means B is the last one. B is the last one. So even in that case, I cannot conclude who was third. So statement 2 alone is not possible. Then combine both the statement. Lecture F is preceded by preceded by A and followed by C, and B is at the end. So B is at the end. So this is one possibility. Other 2 fellows will come here. Or A, F, C, then comes B. Here gaps are there. Or A, F, C, gap, B. This is also possible. So many things are possible here. Or B is at the end. Who is the third person? I don't know. So there are 3 chances. C, A, F. So even by combining both the statements, we cannot answer this question. So answer is D here. Yeah. 54th question. 54th question. A, B, C represent distinct non-zero digits. Okay. Distinct non-zero digits 1 to 9. Suppose X is the sum of all possible 3-digit numbers found by ABC. So how the numbers can be? ABC, then ACB, then BAC, then BCA, then CAB and CBA. So these are the numbers that are possible if we use only 3 digits. If I use DEF, who knows? Yeah. Now, ABC represent non-zero digits distinct. Suppose X is the sum of all 3-digit numbers found by ABC without repetition. Which 3 numbers? I don't know. Which 3 numbers? I don't know. Okay. Now, the 4-digit least value of X is equal to 32. X is the sum. X is the sum. Now, they are asking the least digit. 4-digit least. 4-digit least means we have to look for the least values of ABC. When I take the least values of ABC from 1 to 9, I will look for 1, 2, 3. These are the least single digit numbers that I have. Then if I interchange these 1, 3, 2, then 2, 1, 3, 2, 3, 1, then 3, 1, 2 and 3, 2, 1. So if you add these, yes, you are going to get the sum. This is 12, this is 12 plus 1, 13, 12 plus 1, 13. So 1, 3, 3, 2, 1, 3, 3, 2. This is the least value that is possible. That is correct. Then 3-digit greatest value of X is 888. See, when we were looking for the 4-digit least value, we looked for the least values for X, Y, Z, that is 1, 2, 3. If I have to look for some more lesser value than this 1, 2, 3, I don't have choice. I cannot go to 0. They are asking for non a 0 digit. So 1, 2, 3 is the least possible. So when this sum 1332 is the least possible for this one, then look at the 3-digit greatest value. I don't have a choice. So we cannot go below 1332. So this statement is wrong. Because if I use 0, my purpose gets defeated. So this is wrong. 1 only is the answer. Let us go to the next question. So 54 is done. Now 55. Yeah. There is a number lock which has 3-digit pin. So this is as usual. 3 digits will be there, especially in suitcase and all. We find this 3-digit pin. So usually it contains 0 to 9. That means the first place can be occupied by 0 to 9, 10 values. Second place 0 to 9, third place 0 to 9. So 10 into 10 into 10, 1000 values we can have for 3-digit pin if we are using 0 to 9. So that is 10 into 10 into 10 or 000 to 999. 1000 values we can have. But this one, the pin contains the digits 1 to 7. Pin contains only 1 to 7. There is no repetition of digits. The digit in the pin from left to right are in decreasing order. From here to here, it is in decreasing order. Any 2 digits in the pin differ by at least 2. This to this will be 2 gap. This to this will be 2 gap. Okay. How many maximum attempts does one need to find out the pin with certainty? So here they have to be in decreasing order. So 1 to 7 I can use. So I will directly go for the biggest number here, 7. And the next number should be 2 less than this. So 5. Next number should be 3 less than this. Sorry, 2 less than 5. So this is the first option that I have. But when I use 5, I can use 2 also. When I use 5, I can use 1 also. I cannot use 0. So with respect to 7 and 5 in the beginning, I can have these 3 values. Then coming to 6, I can have 4, I can have 2. Coming to 6 and 4, I can have 1. Yeah, that's it. Then going forward for 5, 5, 3 and 1. That's it. So 1 to 7, we can have how many pins? Maximum 6 pins we can have in this fashion. One is decreasing order and second one is the difference between any 2 numbers should be 2. Minimum difference between any 2 numbers should be 2. This is how we can form these many combinations here. So totally 6 different outcomes we have. Next 56 question. There are 8 equidistant points on a circle. There are 8 equidistant points on a circle. So we have to always divide like this, equidistantly. Yeah. How many right angle triangles can be drawn using these points as vertices and taking the diameter as one of the side of the triangle? So whenever you want to draw a right angle triangle, like it is inherent that the diameter will be the hypotenuse of that circle, of that triangle. So when you are trying to draw a right angle triangle inside a circle, so it is inherent that you are going to use the diameter as the hypotenuse. That is the longest side that we can have in the circle. So in this case, so whichever the angle you make with the point on a circle, you will get right angle triangle for sure. So here they would have just given like point as vertices. That's it. So it is understood. It is understood that the right angle triangle can be made with using the diameter. So whenever you try to do the right angle triangle, diameter will be like inherently involved there. Okay. So now how many triangles I can draw with this particular diameter? With this one diameter, I can draw, this is one triangle, second triangle and the third triangle. 4th, 5th and the 6th. So totally I can have 6 triangles if I take only one diameter into consideration. Like that I can take 4 different diameters. This is one diameter, this is one and this is one. So totally I can have 4 diameters. So 4 diameters, and on each diameter I can have 6 different triangles. 6 different triangles. So 4 6 are 24 is the answer. This is a straight away problem, but you should know the dynamics of this. That is, whenever we construct a right angle triangle in a circle, yes, the diameter will be the hypotenuse of that right angle triangle. That is the longest side of that triangle and also the longest side that we can have in the circle. Longest side. So any chord you take, diameter is the longest chord. So that is what is the crux of this problem. Next, 24 men and 12 women can do a piece of work in 30 days. So 24 men and 12 women can do a piece of work in 30 days. In how many days can 12 men and 24 women finish the work? It appears like anyways we are having the number of men and doubling the number of women, then same thing will be done. But here, see, this is straight away like having 2 equations in 2 variables. 2 equations in 2 variables. But unless we know the value, we cannot solve. So this is as good as we are having a single equation. We have a single equation, that is 24 men and 12 women will do a piece of work in 30 days. See here, only thing that we don't know is the capacity of a man compared to a capacity of woman or vice versa. Okay, if men are more capable, here more men are involved, less women are involved, they are taking 30 days. So here we are cutting down on the number of men, increasing the number of women. So efficiency will be less. Definitely they will take more than 30 days when men are having more capacity. When women have more capacity, let's say, here women are being increased and men are being decreased. So more efficiency will be there. So they will finish before 30 days. If men and women are equally capable, M will be equal to W. Either you take M or W. So 24 and 12. So 36 people at work. There is no differentiation between men and women. So 36 people will take 30 days. Similarly, here also 36 people are working. So they will take 30 days. So answer can be anything. But since we don't know the relative efficiency of men in comparison with women or vice versa, we cannot draw any conclusion here. So that is the thing. We have to understand this. So this is a very tricky one. Generally, if people take that men will be more efficient, so they will end up in marking more than 30 days. If somebody feels that women are more capable, then they will mark this one less than 30 days. If they think that anyways those many people are there, they will finish the work in those many days only, then they will mark 30 days. This is very tricky one, but here we have to apply our common sense and get the answer. Next, 58. This number should be divided by 1261. So this is straight away a factorization problem. Here these numbers are okay, 2-digit number, we are a bit familiar. But this 1261, we should identify the factors of 1261. So how to find out? You start with the prime numbers. You start dividing this by prime numbers. 3, can we divide? No. The sum of these digits is not divisible by 3. So 5, not possible. 7, try. 7 ones are, then 7 eights are, not possible. Then try with 11. I am trying with only prime numbers. When you are checking the divisibility, you start with the prime numbers and end with the prime numbers. You will get all the factors involved. Okay, you don't have to try with any composite number while dividing. So here I tried with 3, 5, 7, not possible. I will go with 11. So 11 ones are 11, then 11 ones are 11, it is not possible. Then 13, yeah. So 13 nines are, then 13 sevens are 13 nines are 117, then 13 sevens are. Now this 97, can we divide this 97? Is it a prime number? Yes, this 97 is a prime number. So whenever I divide this number by 1261, I am going to cancel 97 ones are and 97 13s are. And here 13 ones are and 13 sevens are. So this entire expression is divisible by 1261 perfectly. Then when a number is divisible by other number perfectly, then the remainder will be equal to 0. Remainder will be equal to 0. Remainder will be 0. So here we can directly say the remainder is 0. Remainder is 0. This is what is the crux of the problem. Only thing we have to decipher this 1261. Decipher this 1261. So that is where the remainder will be equal to 0. Okay. So this is no tricky problem. No tricky problem. Just we have to know the division and we have to know how to factorize a number. Next question, 59th. Consider the following statements in the respect of a rectangular sheet of length 20 centimeter into 8 centimeter. 20 centimeters into 8 centimeters. It is possible to cut the sheet exactly into 4 square sheets. It is possible to cut the sheets exactly into 4 square sheets. What I need is like 4 squares. That means 4 into some square area. So square area here 8 into 20 is 160. 8 into 20 is 160. So 160 divided by 4. So I need to get a particular square with 40 square centimeters. I need the square of 40 square centimeters. 40 square centimeters. This is what is the challenge here. This is what is the challenge. And when I take 40 as the square area, 40 as the square area, I have to take square root of this, that is root of 40 as a single side, because I need 4 square sheets. In the rectangular sheet of 20 centimeter into 8 centimeter, I need 4 square sheets. So this is what is the challenge. So here 8 is there, 8 is there. So if I cut 8 and 8, so this is 8 cross 8, 8 cross 8, but I am left with 4 here. I am left with 4. So if at all you want to get this into square sheets, what we can do is, so here this is 8 and this is 20. We have to go for the HCF of 8 and 20. HCF of 8 and 20 is 4. What I can do, like this 4 into 4. Then here 1, 2, 3 and 4. So here 4 into 5. So I will have 10 squares of 160, 10 squares of 16 square centimeter each. So this is not a possibility here. This is not a possibility here, because root 40 is equal to 2 root 10. So it is very difficult to get that dimension. So let us look into the other statement. It is possible to cut the sheet into 10 triangular sheets of equal area. 10 triangular sheets of equal area. How to do that? 10 triangular sheets of equal area. Anyways, we have 8 cross 20. We have 8 cross 20. So 20 here and 8 here. And we need 10 triangular sheets. So if I have 160 square centimeter here, divide by 10. So I should get 16 square centimeters. I should get 16 square centimeters, and all of them should be of equal area. All of them should be of equal area. So I need 16. So how do I get the rectangular this one? So usually half into A into B. This is what is the area of a triangle. Area of a triangle is half into A into B. So this has to be 16. So 1 by 2 into A into B. So 32. So A into B should be 32. A into B should be equal to 32. So what I can do here is, so I need 32. One side is 8. So if I cut this into 4 centimeters each. So here 4, here 4, here 4, here 4, here 4. So now I have got 4 into 8 rectangles. So 4 centimeter into 8 centimeter rectangles. So totally 5 rectangles are there. So if I directly cut like this, I will get like 10 triangles of equal area. 10 triangles of equal area is possible with this, because clue was what? Area is 16. So A into B should be 32. Already 8 is there. I need 4 here. So that is the end of the problem. Only the second statement is correct. First statement is wrong. It is very difficult to get the squares out of this rectangular sheet. If at all you will get the squares in the sheet, that square should be of the dimension 4 centimeter into 4 centimeter. So totally there we would get around 10 squares. But yes, 4 squares is not possible. 60th question. 70% of a number. See, 70% of a number x is added to another number y. The sum becomes 165% of y. So if I bring y this side, so this is 70 by 100x is equal to 65 by 100 y. So 100 get cancelled. This is 5 13s are and 5 14s are. So here x by y is equal to 13 by 14. So in this case x is lesser than y. X 13, y 14. So x is lesser than y. This is what is the clue that we have. Then when 60% of the number x, 60% of number x is added to another number z, then the sum becomes 165% of z. So 60% of x is equal to 65 by 100 of z. 0000 get cancelled. So x by z is equal to 65 by 60. So that is 5 13s are and 5 12s are. So x by z is equal to 13 by 12. X by z is equal to 13 by 12. In this case, z is less than x. Here x is less than y, z is less than x. So what I get? Z is less than x and x is less than y. This is what is the relation that we get. So out of this detail, what is the answer? Z is less than x and x is less than y. So this is what we have. Okay. So this is a straight away problem. Like first equation is giving the comparison between two variables. Then the next one is giving the comparison between two variables. That's it. So here we can solve this question very easily. Not troublesome at all. Next question, 64th. Two candidates X and Y contested an election. 80% of the votes cast their vote, 80% of the voters cast their vote, and there were no invalid votes. There was no nota. That means 80% of the voters cast their votes. So if the number of voters are V, 80% of them casted the vote. So this is the number of votes that we have got. There were no invalid. None of them were invalidated. then there was no nota also. That means all these have gone to X or Y. All these have gone to X or Y. If it was nota, then they have not gone to X or Y. So here either X should get or Y should get. Then X got 56% of the oats cast. Oats cast are 80% of the voters. 80% of the voters. So this is what is got by X. This is what is got by the X. 60% of the oats cast. 56% of the oats cast. Oats casted are this and 56% of that. And 1 by 1440 votes. So how much should have Y got? Y should have got the remaining votes. If 56% is got by, if 56% is got by X, another remaining 44% are got by. So this is multiplication 80 by 100 V. This is got by Y. This is got by Y. What is the difference altogether? What is the difference altogether? X minus Y is 12 by 100. 12 by 100 into this 80 by 100 V. This is equal to how many votes? 1440. The difference between X and Y were 1440. Now, here if you cut this 0, 0, then if you take this all the numbers on the other side, V is equal to 1440 and 100, 2 zeros, and 10, 1 0, divided by 12 into 8. So 12 ones are 12, 12s are, then 4 zeros, then 8 ones are, 8 15s are, and 3 zeros. So totally V is equal to 15,000. They are asking what is the total number of voters? 15,000. So simple here. Everything is given in terms of the number of voters. X has got 56%, Y has got 44%. So X got 12% extra. That 12% extra is nothing but 1440. X percent extra that they have got is nothing but 1440. So 12% is nothing but 1440 and of those many voters. So finally what we have got? 12% of this 80% of the voters is equal to 1440. So the answer is 15,000. This is just a substitution problem. What is the smallest number greater than 1000? Smallest number greater than 1000. So we are looking for a 4-digit smaller number. When divided by one of the numbers 6, 9, 12, 15 and 18 leaves a remainder 3. So whenever we divide a number that is more than 1000, a smallest number greater than 1000, when divided by these things, we will get the remainder as 3. So for this, we have to take the LCM of these numbers for such questions. Take the LCM of this. So what is the LCM here? LCM will be 180. You work out, LCM will be 180. So when you try to divide this 1000 by 180, then what you will get? What you will get? So 180 5s are 900 and I will be remained with 100. If I add 80 to this, it will become 1080. So 1080 divided by 180 is equal to 6. So 1080 is that number. So how do you get this 80? The difference between these two is equal to 80. Add this to this 1000. So 1080 is that smallest number divisible by 6, 9, 12, 15 and 18. So 1080. Whenever we divide that 1080 by this one, so I should get the remainder as 3. So the answer is 1083. This is a very classical problem. This has been asked since many years in many of the competitive examinations. This is a classical problem. One should not miss. So whenever you are dividing a number by many numbers, take the LCM and divide. Simple. And whenever you are looking for a largest number or the smallest number, so try to divide that smallest number and the largest number by that LCM and do the rest procedure. And if you want that remainder, add that remainder later. So in this case, that is 3 and the answer is 1083. Let P be the 2-digit number and Q be the number consisting of same digits written in reverse order. So if there is one number, this is P, and Q is the number like when reversed. So this will come here and this will come here. So this is such a number, and P into Q is equal to 2430. 2430. So when I multiply these numbers, I should get the product as 2430. So what does that mean? What does that mean? See, I want the number ending with 0. I want the number ending with 0. So when do you get that? Either of them should be divisible by 5 or 10. Either of them should be divisible by 5 or 10. So here I cannot take 0. I cannot take 0 here because when I reverse that, 0 will go there. That cannot qualify as a 2-digit number. So 0 is ruled out here. Now I will have to think of 5. So if this is 5, 5 has to come here. 5 has to come here. So if you look at this way, and we want 2430. 2430 has to be divided by a number which is closer to 50. So when I try to divide this number by 50, I will get some answer starting with 4. When I try to divide this 2430 by 50, I will get some number which is like just more than 40. So in that case, fill this as 4. So here 4. So 54 into 45 is nothing but 2430. In that case, what is P and what is Q? It can interchange. Either it can be 45 and this can be 54, or this can be 54 and this can be 45, anything. But these numbers P and Q are 45 and 54, which is what? We don't know, but definitely between 45 and 54. Now, then what is the difference between P and Q? So anyways, they are asking the difference. Either P is bigger or Q is bigger, the difference will be 9. So that is the answer. Next, consider the following statements in respect of two natural numbers P and Q such that P is a prime number and Q is a composite number. And if you look at the statements here, can be. I have told previously also, when they ask can be and maybe, you have to prove only once. If that is true even in one case, yes, that is true. You don't have to disprove it. But when they ask certainly, definitely, is, are, then we have to prove in every case. Rather than that, we have to just disprove in this one case. So, P into Q can be an odd number. When you will get odd product? When both of them are odd. Odd into odd is equal to odd. So, can I get the odd prime number? Yes, except 2, everything is odd only. Then Q is a composite number. Can I get any odd composite number? Yes, 9 is the first odd composite number. 3 into 3 is 9. Composite number is nothing but a non-prime number. But 1 is neither prime nor composite. Okay, so 9 can be that number, so that can be odd. Now, Q divided by P can be a prime number. Q divided by P. So, one composite number divided by a prime number. Can it be a prime number? Yes, I will take Q as 9 and P as 3. Again 3 is the answer, 3 is prime number. Or 15 divided by 3, 5. 5 is a prime number. Yes, possible. P plus Q can be a prime number. P plus Q can be a prime number. Except 2, all prime numbers are odd. All prime numbers are odd. So, you have to take 2 here. So, 2 plus 3 is equal to 5, or 2 plus 5 is equal to 7. This is also prime, this is also prime, this is also prime, and this is also prime. So, this is also possible, can be. So, all 3 are correct. So, one clue here, whenever they give can be and maybe, so mostly we can prove that. Mostly we can prove that. Whenever they say certainly, definitely, is and are, There we have to be extra careful. That's it. Between 3:16 p.m. and 3:17 p.m., hour hand and minute hand coincide. Yes, in this case, one simple thing you have to do. They are asking after 3 o'clock. After 3 o'clock, just take this magical fraction and multiply by the hour that has been passed. So 60 by 11 into 3, it will give me 180 by 11. This is the minutes. So at this minute, they will coincide. 180 by 11 is nothing but 16 integer 4 by 11 minutes. So somewhere after 3:16 and before 3:17, they will meet. After 3 o'clock, they will meet at this time, after these many minutes. So this is correct. So if they ask for anything, for example, if they ask 4 o'clock, so 60 by 11 into 4, you will get 240 by 11. So somewhere after 22 minutes and before 23 minutes, that is when they coincide. This is what is the clue. Please remember this 60 by 11. 60 by 11 into that number, you will it will get you like how many minutes after that hour they will coincide. Okay, this is done. Now, between 4:58 and 4:59, both minute hand and second hand. See, generally in clocks chapter, we see the relation between the minute hand and the hour hand. But generally we don't see the minute hand and the second hand, because second hand will be continuously moving. By the time it finishes one round, the minute hand has just moved by a bit, that is 1 minute. So basically, the speed of the second hand is 60 times faster than the minute hand. In that case, it is very difficult to see where that is coinciding. But every minute, like it will have the coinciding point. But here they are asking 4:58. Here they are asking 4:58 to 4:59. They will coincide. So one thing I'll tell, exactly at 5 p.m. So this is our hand, this is minute hand, and even the second hand will coincide with this at 5 p.m. But just before this, they will be meeting, the minute hand and the second hand, they'll be meeting before 4:59. They'll be meeting before 4:59. Between 4:59 and 5 o'clock, they will not meet. But between 4:58 and 4:59, they will definitely meet. So this is also correct. But this is bit odd. This is bit odd problem. Like I generally don't see this problem. There can be a chance of just a mistake in the printing, but it is not the case. They are meaning the concept properly. But our chapters, when we relate our chapters to this thing, so usually we don't go to minute hand and second hand coincidence. That is too complicated. So there generally we don't see such a this thing. So still okay. We can consider that one. Maybe next year also they may ask such a problem. We have to be prepared, but don't pay in-depth attention to that detail. Okay. So when question comes, you can handle in the examination all also, but preparation for that will simply complicate your life. So let us not focus on that. Next, there are two containers, X and Y. X contains 100 ml of milk. So this is X and this contains milk. And Y contains 100 ml of water. 100 ml of water. So both are containing 100 ml. After mixing well, 20 ml of the milk from X transferred to Y. After mixing well, 20 ml is transferred back to X. Volume wise, both will be 100 ml. volume wise both will be 100 ml because we are just transferring this to this and this to this. So basically here there was pure milk, this has been diluted. There was a pure water, it has been contaminated with the milk. So here pure milk is disturbed and here pure water is disturbed. But how much of adulteration has been done here and how much of like contamination has been done here if you look at, let's see. If M denotes the proportion of milk in X and if N denotes the proportion of water, anyways both will be having 100 ml and 100 ml. Now let's say around M is remaining, M of milk is remaining here and N of water is remaining here. What will be the rest? So if M is this one, some extra will be what? Some extra will be here water and here the same amount of extra will be milk. Here M is milk and N is water. But how much milk we are missing? How much milk we are missing here? X. And the same amount has gone there. How much milk has been lost here? That amount of milk is here. That means M and N are same. But to simple it very, to put it very simply, water is contaminated, even the milk is contaminated. Both are 100 ml. Some milk is lost and some water is lost. The lost milk has come here, lost water has come here. There is remaining some milk, there is remaining some water. How much milk is remaining? The same amount of water is remaining here. But here in this question, the student will confuse M as the milk remaining in the container X and N as the water remaining in the container X. They think that is where they go wrong. But here we are checking at the purity of the milk. If M is the proportion of milk in X, N is the proportion of water in Y. Water in Y, not the milk. So how much milk is contaminated here, the similar amount of water is contaminated here also. That is why M is equal to N. So this is a bit confusing. You can watch this particular solution again and again and you can get the clue. Next question. A pie chart gives the expenditure on 5 different items A, B, C, D, E in the household. B, C, D, E correspond to 90 degree. Let me take this as 90 degree, that is B, 90 degree. Let's take this as C, that is 50 degree. Let us take this as D, 45 degree. So this is 90, this is 50 and this is 45. This is just above this one, 180 degree now. Then 75. So 75 will be somewhere here. So now check, 90 plus 50 is 140, 140 plus 45 is 185, 185 plus 75. It is 185 plus 75 is 260. So remaining is 100. This is the angle left for A. They are asking what is the percentage of expenditure on item A. So out of 360 degrees, 100 degrees dedicated to A alone. Out of 360 degree, we are dedicating 100 to A alone, and they are asking now the percentage. This fraction is how much percentage? 0, 0 get cancelled. 4 9s are, then 4 25s are. So 25 into 10, 250 divided by 9. So 9 2s are, or 250 by 9, directly it is there. So that is the answer. So here simple, whenever we want to convert the angle into the percentage, you have to take the fraction. In that fraction, 360 degree will come in the denominator and that pi will come in the numerator and into 100%. This is what you have to do. This is what you have to do. Okay. So this is totally 250 or directly you can take that angle, let's say here 100 degree and divide that by 3.6. Divide that by 3.6. That is what is happening. 100 here and 360 here. Directly you can divide it by 3.6. So 100 divided by 3.6. So that is nothing but 250 by 9. 250 by 9. Next. If this expression is written as 3 to the power of m into n. So what do we want here? 3 to the power of m means 3 into 3 into 3 into 3 for n times. N times 3 into 3 into 3 into 3 m times. So in this case we have to identify the multiples of 3. So 3 will come, then 6 will come, 9 will come, 12 will come and 15. So totally 15. So instead of that, what we can do, take the highest value here, that is 15. 15 divided by 3 you do. So 5 multiples of 3 will come. 5 multiples of 3. But in that 5 multiples, like how many are giving me another 3? For example, 9. 9 is nothing but 3 into 3. So 5 divided by 3 will get me 1. So those many 3's I will get, 5 plus 1. For example, in 3, 1 3 is there. In 6, 1 3 is there. In 9, 2 3's are there. In 12, 1 3 and in 15, 1 3. So totally 6 3's are there. So the value of this is 3 to the power of 6. So m is equal to 6. M is equal to 6. So we get those many 3's. So m is equal to 6. So in this case, what you have to do, take the highest number and divide it by whatever they have given and get the answer. Let's say here 5. Again take this 5 and divide by 3. Again you will get 1. 5 plus 1 is equal to 6. For example, that number is 24. 24 divided by 3 is equal to 8. 8 divided by 3 is equal to 2. 8 plus 2 is equal to 10. So this is how we have to do. Next, what is the value of x in the sequence 2, 12, 36, 80, 150? So here what we have to do, like 2, 12, 36, 80 and 150. So here take the difference, 10, here 24, here 44 and here 70. Again take the difference, 14 and here 20 and here we get 26. So look at this, there is a 6 increase. 14 plus 6 is 20, 20 plus 6 is 26. Apply the same thing. So here 44 plus 26 is 70. So 26 plus 6 will give me 32. 70 plus 32 will give me 102. 150 plus 102 is 252. So answer is 252. So this is a simple classical problem. First you have to do in this sequence the difference between two consecutive elements and go on doing the iterations until you get one common difference. You go on doing those iterations. At least in 2 or 3 iterations you will get the answer for sure. One non-zero digit, one vowel and one consonant from English alphabet in capital are to be used. See, one non-zero digit, that is 1 to 9. Then one vowel, so 5 vowels are there. Then one consonant, 21 consonants are there from English alphabet, are to be used in the passwords such that each password has to start with a vowel, so one is vowel, and end with the consonant. So now comes the number here. So how many vowels I can use? I can use 5 vowels and consonants are 21 and numbers that I can use non-zero digits is 9. So 5 into 9 is 45. So 45 into 21, that is 945. 45 into 21, it is 945. So this is a simple problem. One who knows the permutations and combinations can easily solve this problem. Next. There are 9 cups placed on the table arranged in an equal number of rows and equal number of columns. Okay, so there are 9 cups, equal number of rows and equal number of columns is nothing but 3 in the rows and 3 in the columns. So this is what we have to see, 3 into 3. Now, out of which 6 cups contain coffee, out of these 9 cups, 6 contain coffee and 3 contain tea. In how many ways can they be arranged so that each row should contain at least 1 cup of coffee? At least 1 cup of coffee should be there in each. At least 1 means 1 or 2 or 3. These are the number of cups of coffees that we can have in any row. So 1 or 2 or 3. Let me go with 1 first. Let me go with 1, at least 1 coffee. Each row 1 coffee. So other 2 have to be tea. But how many teas we have? Only 3 teas we have. Only 3 teas we have. So if I go with 2 now, if I go with 2, yeah, 2 coffees and 1 tea. So in how many ways I can arrange this? For example, this is coffee, and this is tea. This is coffee, and this is tea. How many ways I can arrange this? See, CCT is 1, CTC is 1, TCC is 1. So 1 row, 3 ways I can arrange. 1 row, 3 ways I can arrange. Similarly, this is 3 and this is 3. So 3 into 3 into 3, then only my job is done. 27 ways when I use 2 coffees and 1 tea. Now, what I will try to do? Now, I had taken equal number here, either 1 or 2. 1 coffee is not enough. We have to take 2 coffees if you want to have the uniformity. Now what I'll do? If I take 3, no, 9 places coffee is not there, 9. So 3 cups of tea is there. So then what I can do? In this row, I can use 1 coffee and 2 teas. Okay. In this row, I can use 2 coffees and 1 tea. And in this row, I can use all 3 coffees. This is one more possibility. Either 2, 2, 2 in each row or 1, 2, 3. And these numbers can vary. 1, 2, 3, 2, 3, 1, 3, 2, 1, anything can happen. So first of all, let us look at how many ways we can arrange like this. This row can come here, this row can go there. All 3 are different rows. So I am not interchanging these teas and coffees. I am changing the rows themselves. This row will come here, this row will come like this. So totally 3 factorial ways I can arrange the rows. I am not yet touching the tea and coffee interchange. I am not interchanging them. So 3 factorial ways. 6 ways of arranging the rows. 6 ways of arranging the rows. Okay. Now, in each row, in how many fashion I can arrange this? CTT is 1, TCT is 1, then TTC is 1. So these are 3 ways of arranging 1 row. 3 ways of arranging 1 row. Second row, CCT, CTC, then CCT, then TCC. So 3 ways of arranging the second row. Third row, there is no change. All are CCC only. So there is only 1 way. So 6 ways of arranging the rows. Inside the row, I can arrange 3 into 3 into 1. I can arrange 3 into 3 into 1. So this is totally 6 into 3 into 3, that is 54. Then here I have other 27 ways of arrangement. When I take 2 coffees and 1 tea in each row. So 27 here, then 54 here. 27 plus 54 is 81. This is one of the toughest problem. This is one of the toughest problem that we have, because they have randomly given 6 coffees and 2 teas. 3 teas. 6 coffees and 3 teas and 3 different rows. So here the comprehensibility of this particular problem, like it is not the cup of tea of everyone. So everyone cannot understand this one. So your IQ level has to be extraordinary to understand this problem. So that is why this CSAT paper is just passing paper. So such questions you have to identify and leave in the beginning. Leave in the beginning. Okay. So first of all, there are 2 ways. That is, each row contains 2 coffees and 1 tea. Another way is having 1 coffee in one row, 2 coffees in another row and 3 coffees in another row. Rest all are tea. So when it comes to 2 coffees in each row can be arranged in 3 ways. So 3 into 3 into 3, that is 27. When it comes to 1, 2, 3, first row can be arranged in 3 different ways. Second row can be arranged in 3 different ways. Third row, no change possible. 3 into 3. So that is 9. But totally, the rows can be interchanged. Rows can be interchanged the way we want. Rows can be interchanged the way we want. That is 3 factorial ways. So that is 6. 6 into 3 into 3 is 54. And earlier, 27. 54 plus 27 is 81. Next question. The sum of 3 consecutive integers is equal to their product. Integers, not just positive integers, it can be negative also, it can be 0 also, whose sum is equal to the product. So you can think of only the smallest numbers here straight away, like the sum 1 plus 2 plus 3 is equal to 1 into 2 into 3. This is the only chance when you are using all positive numbers. All positive numbers, because we are hitting the lowest positive numbers. Next, if you want to use both positive and negative, so this is minus 1 plus 0 plus 1. So minus 1 into 0 into plus 1. So both are equal to 0. Here 6, here 0. But we can use all negative integers. So minus 3 into minus 2 into minus 1. So that is equal to minus 6. So 3 such triplets are there, which will give us the product is equal to the sum. So this is where 3 such possibilities are there. What is the numbers of the form point x, y, where x and y are distinct non-zero digits? Non-zero digits 1 to 9. So how many ways I can fill this place? 9 ways. Anything from 1 to 9 I can place here. So 9 different ways. But what I use here, I should not use here. So this can be used in 8 different ways. So 9 into 8 is equal to 72. 9 into 8 is equal to 72. This is the simplest problem that we can come across. Okay, next. The average weight of ABC is 40 kg. So that is A plus B plus C divided by 3 is equal to 40. This is what we have. The average weight of BDE, B plus D plus E divided by 3 is equal to 42. Then the weight of F is equal to the weight of B. Weight of F is equal to the weight of B. So F is equal to B. Then what is the average weight of A, B, C, D, E, F? A, B, C, D, E, F. So here B is there, here B is there. Instead of this, I'll put F. So here A plus B plus C, A plus B plus C is equal to 120. And here D plus E plus F is equal to 42 into 3 is 126. If I add this, so totally I'll get A, B, C, D, E, F. Then 120 plus 126, it is 246. So 6 people weight is 246. If you want their average, this should be divisible by 6. So that is equal to 41. So this is like equations. First you have to solve the equations, then you have to get the value of A plus B plus C, then D plus E plus F. First is A plus B plus C, then D plus E plus F. So total is equal to 246. If you divide that by 6, the average is 41. So with this, we have solved 2022's paper also. In the next, we will be solving 2021, then 2020 and so on. So please keep referring to these videos for the utmost clarity in CSAT paper. And if your IQ level is more than average, yes, with these solutions and the practice of these again, you will clear the CSAT paper for sure. So until the next time, all the very best and thank you very much.